Hey, he's not.
I am not joking. Where do you get this idea from?
He's not negotiating.
When you take the AP test, any reference will be provided in the question. You will not have auxiliary reference materials. Alright, this is problem 10. This is page 92.
There we are.
Alright, time t equals 0. A diver jumps from a platform that is 32 feet from the water with an initial velocity of 16 feet per second. So my v sub 0 equals 16. Draw a picture that depicts this situation, labeling all relevant information. Now, if the initial velocity is 16 feet, which direction is he jumping? Up. Okay? So remember position, okay? Position is how far off the ground are you? So he'd have to be like diving straight down, and it would have to be negative. Okay, that made no sense. Let me start over.
Yeah.
All right.
Yeah.
So when the diver, he's basically jumping into the air, not just falling off the platform. Okay? In fact, it's really hard to have a negative velocity from the diving platform, unless you're hanging upside down.
Yeah.
You understand what I'm saying?
Yeah.
I mean, so he's going to have to jump into the air before he starts going down. All right. So it's positive velocity if you're going away from the ground. It's negative velocity as you go towards the ground. Okay? So he is jumping up first before he starts going down. So he has initial velocity of 16. All right. So he's basically, so here is the platform. He's jumping up and going down.
Ah, I see.
Okay? So in fact, the parabola is going to look something similar to that. All right. The position equation. So remember the position equation looks like this. It's going to be negative 16t squared. So this part is almost always going to be the same for your position equation, right? It's half. We're assuming this is planet Earth. If it is not planet Earth, they will tell us. Okay, and they'll go on and on about how it's not the planet Earth. Okay, so it's negative 16t squared plus the initial velocity, which is 16t, plus the initial position, which is 32 feet from the water. So that is our position equation. Velocity equation. So you're going to take the derivative of the position equation. So the velocity equation is the derivative of the position equation. So it's negative 32t plus 16. And the acceleration equation, as long as you're on planet Earth, it should always be the same. So acceleration equation is the derivative of the velocity equation, which is the second derivative of the position equation. Am I going too fast?
Is that V of A or is that A of T?
That is a mesh, A of T.
Is that an equal sum between V of T and S of TT?
Yeah.
S of T.
Yes, that's an equal sign.
Is
So
that
just negative 32?
Negative 32. Yes, ma'am. Now, when does the diver enter the water? So this is asking, when does the diver hit the water? So which equation are we going to use to figure that out?
Position?
Position, right? We want the position to be 0. So we're going to set this puppy equal to 0.
Oh, wow.
So we're going to say negative 16t squared. Let me zoom in. So we don't need all that space.
You have to work all that out.
What do you mean?
Isn't it just 32? Oh, wait.
Does 32 answer when he hits the
You
water?
don't plug 0 in? You,
0 means when he jumped off the platform. Right? If t equals 0 would mean when he jumped off the platform.
okay. Yeah.
Alright. So what I'm going to do is set this equal to 0 and solve it. The easiest thing to do right now is just divide by negative 16. That'll give me t squared minus t minus 2 equals 0. So they conveniently gave us an equation that's factorable. So t minus 2 times t plus 1 equals 0. That gives us t equals 2 and negative 1. Which one of these answers makes sense? 2, after 2 seconds. So after 2 seconds, it hits the water. 2 seconds, the diver enters the water.
Would it always be nice answers like that, or like 2.5?
Okay, good question. No, it will not always be nice answers. However, if it's one of those like homework problems, it'll probably be a nice answer. But I would not count on that for the AP test, especially if it's a calculator question. Okay, so the not nice answers is going to be those calculator questions.
Because you'll just plug like square root of something.
Yeah.
Shouldn't we say the answer in like terms of minutes?
In terms of minutes?
Yeah.
Why?
Because that's what's in the question.
Sorry?
Feet per second. Oh, I guess not.
It says when does he enter the water, right?
Yeah.
You think he's going to be in there for 2 minutes?
No, I was saying, shouldn't we say it like 260 a minute?
Why?
So we say it in terms like time in terms of minute instead of seconds.
Isn't seconds also time?
It is.
So what's wrong with just using seconds?
Oh, I thought we had to say it in terms of minutes.
I'm pretty sure.
Nothing has been given to us in minutes. Everything's been given to us in seconds.
I'm pretty
It's
sure
feet per
seconds is
second.
like the base unit for time.
Right. Minutes doesn't make sense in this context. If the gravity is like on a moon, then maybe in terms of minutes, because the gravity will pull us so slowly. Except even on the moon, I still think it'd be seconds.
Yeah, but you can say like.
You could, but
60th second.
yeah, but you just like fractions. Is that what it is?
No, I'm just saying. I think you're supposed to put it in terms of minutes.
I don't know how you get that.
What's
Nothing
the-
is given in terms of minutes.
Does the sun have a gravity?
All right. Does the sun have gravity?
Yeah.
All right. What is the velocity at the moment he enters the water? So he enters the water at 2 seconds. So that means we look at the velocity at 2 seconds. Right? So we're using the v of t, which is negative 32t plus 16. So that's going to be negative 32 times 2 plus 16. And make sure I do my arithmetic correctly, please. I'm getting negative 48. So he's falling at 48 feet per second.
A lot of feet per second.
Say what?
That's a lot of feet per second.
Is it?
Yeah.
Whoa, that's pretty fast.
Yeah, that's fast.
Is it?
Like 48.
I mean, he's falling now. He's not running.
like 48 miles an hour is like really fast, but that's like way bigger.
No, not.
Is it now?
Wait, which one's faster, a mile per hour or a
Okay,
foot
feet
per
per
second?
second. Feet per second is like faster.
Feet per second just
Part E.
shorter distance.
When does the diver reach his maximum height? When does the diver reach his maximum height? Now, going back to my diagram, he reaches the maximum height at the vertex of the parabola. So that means we need to know when is the derivative equal to 0? When is the derivative equal to 0? So in other words, when is velocity equal to 0?
Oh wow.
Okay, when is the velocity? In other words, he's going up, and then for that 1 second, and just that one moment in time, his velocity is 0.
It's probably less than a
So
second.
you plug in 0 to the velocity equation?
Right, so that'll be 0 equals negative 32t plus 16. Now, you're not plugging in time equals 0, you're saying the velocity is equal to 0. Okay, so then you solve this equation, which would be what?
1/2.
1/2? T equals 1/2?
That's
Yes.
the answer. Why
Negative
do
one?
you-
What's the point of taking the derivative of these questions?
Well, 1, I just answered that question using derivative.
How does the derivative affect how high you go?
It doesn't. It tells you what your velocity is during that flight.
So is it 1/2 seconds?
1/2 seconds, yeah. Right, so when does the diver reach his maximum height? Is that time equals 1/2 per second. And what is the diver's maximum height? So I use the derivative to find out when he reaches that maximum height. Now I use the position to find out what the actual height was.
Oh, so when you use it, that
So F
Right.
of 1/2 or S of 1/2.
S of 1/2.
Wow.
Oh.
It's a lot of work.
It's a lot of work.
That's not.
Is that -4 plus 8 plus 32?
So is that like remote?
That's the position.
Okay. Not the what, the
How'd you
when.
get all that?
When is the half, right?
Yes.
That's a point in time.
Okay.
How'd you get all that?
Do you square the 1/2?
Yes. Right? Square the 1/2, you get 1/4. 1/4 of negative 16 is negative 4. Half of 16 is 8. So you get a final answer of what? 36? 36. So he reaches a maximum height of 36 feet.
Where did he start at?
32.
So like, what are they measuring? Like, when he was on 32 feet, like his head is probably like 6 feet above his feet.
His feet.
His
His
feet.
feet are at 0 or 32.
His feet are at 32.
But what if
So
he
his
turned
feet
upside
reach
down?
36.
He did not jump no 4 feet. Oh my
Well, that's a
God.
good question, but
It's just
I
like-
won't get picky about that.
You bounce. Oh yeah, we don't have the bounce number.
Yeah, what if
Have
the
the
board
bounce.
like dips low?
This is a platform, not
He did
a
not jump 4 feet.
diving board.
He has a 4-foot vert.
There's no way. He jumped 4 feet.
How did he has a 4-foot vertical?
Well, look at his initial velocity. That's pretty fast. So he kicked off really hard.
Yeah.
I guess.
Look, hey. Just to let you know, they made these numbers up so it's easy to do the math. If you want real numbers,
He has a 48-inch.
it'll be much more complicated. All right?
That's true.
So don't complain that this is not quite realistic.
It was LeBron James.
All right, last question. What is the diver's average velocity from the time he hit his maximum height to the time he entered the water? So the time he hit his maximum height was at half second, right? So that means we need to know, so t equals 1/2 is the time, the initial point in the interval, initial time in the interval. The time he entered the water was at when? Did we answer that question?
2 seconds.
2 seconds. So we're looking at t equals 1/2 and t equals 2. To find the average velocity, we just find the slope between those 2 points. So that's going to be, so average velocity,
Doesn't matter which one. we do
velocity
first.
average, it does not, it's going to be f of, or s of 1/2 rather.
Wait, S or?
S of 2 over 1/2 minus 2. And if you like to do it the other way, that's fine. And what was s of half? 36? And s of 2 is 0, right?
What do you mean X?
S of position. We're using the position.
Oh, okay.
And that's negative 3/2 on the bottom? Yes?
That's 1/2 of 36.
Wait, what is that? What is that? That's equal-
S is the position
That's
function.
1/2.
You just plug it in.
Oh, okay.
They already sell that.
Yeah, okay.
Huh?
Thank you.
Hello?
So negative
I hear a
24.
bunch of questions
Negative
being
24.
muttered, but I can't understand the
X is
question.
equal to 36.
Yes, we just found that in part F.
That's 1/2.
So S times 1/2.
It's not S times 1/2, it's S of 1/2. This is functional notation.
Okay.
Alright, so 36 times negative 3/2.
Negative 24.
Oops, I'm sorry, negative 2/3. Is what? Negative 24?
Yeah, that's a lot of work.
So his average velocity is negative 24 feet per second.
Negative?
It should be negative because he's falling. But if you said he's falling, then you'd have to take the negative off. Yeah.
So which is faster, a feet per second or a mile per hour?
Those are just units of measure. You can't say one's faster than the other. Right? It's like saying, just because it's miles per hour that it's faster than feet per second. That would depend on what the actual
A million
values are.
feet per second
Oh,
is
like-
faster than 1 mile per hour.
1 feet per second is
A
faster.
Faster
Million
than what?
feet per second is faster than 1 mile.
Well,
per hour.
yeah. But like, which one's?
Right, yeah, but you just asked which one's faster.
Well,
He answered your
A
question.
million versus one, obviously, is gonna be millions. But like, what?
Like it's a mile per hour.
Which one's farther, 10 feet per second or 10 miles?
So like 1 mile per hour.
You do the math. You do the math. You're just stalling.
Wait, so you're
I don't
saying
actually
1
believe that
feet
you
per
can.
second and 1 mile an hour?
All right, moving on.
In 1 second.
Like which one is
All
faster?
right. Number 22. So I am going to do like 3 of these, and you're going to have to do 3 of them for homework.
That's fine.
All right. Determine if the function is continuous or non-continuous. differentiable or non-differentiable. Now, when it says, whenever it mentions continuous or non-continuous, it means at any point. Okay? So if it's not continuous at any point, say so. If it's not differentiable at any point, say so. Okay?
If it says a point, specifically, do we focus on that point? Like if it says continuous,
Like you don't have to give me the actual point. You can just tell me it's continuous or not continuous, or differentiable or not differentiable. Alright, so looking at this function, x squared and x. So x squared, where x is greater than or equal to 0, looks like this. Let's see, at 2, it's what, 4? So it looks like that. Do you understand what I just did?
No.
Alright, I know what x squared looks like. Do you know what x squared looks like?
Little curvy thing.
Yeah.
A half a parabola.
No idea.
It's a half a parabola. Alright, so x squared, I'm going to do this in pencil, looks like, let's see, 1, 2 is 1, 2.
That's negative x squared.
This is x squared.
Yeah, that's about
This is x squared. But it said where it's greater than 0, so I don't need this half.
Oh, now I get it.
I get it.
Because when it's negative x, it's still going to be positive.
So then is the other half linear?
Alright, and then when it says x is less than 0, you just want the line y equals x. So that's here.
So it's just linear?
Oops. Yeah. Well, that's y equals x, right? That's the line y equals x. But I only want it when x is negative.
So you want me to draw a dotted line or an actual line?
Line.
Why'd you do the little
It's
dots?
equals x.
That's weird. But why'd you do those dots then?
So I can draw it properly.
Well, I guess.
Sorry.
It's hard.
Alright. Now, is it continuous?
Yes.
Yes. Now this is the weird question. Is it differentiable?
I don't know.
No.
No, what does that mean? Not.
Okay, so it's not differentiable. Alright, now, we're talking about this point here. The problem is, the way I drew it, it's kind of hard to tell that it's not differentiable. Okay? So let's look at this. What is the derivative of this function? So whenever you have a piecewise function and you take the derivative, you do it separately. So derivative of x squared is 2x, and derivative of x is 1. And this is for x is greater than or equal to 0, and x less than 0. Yes?
You said this is different, it's not differential?
It's not differentiable at x equals 0. Yeah.
Okay, if x were less than or equal to 0 for the second piecewise, would it be differential then, or no?
Okay, I understand the question.
So would it stay like not differential if x were to equal or would be less than 0 on the second piecewise?
Okay, do you know why it's not differentiable? How about you let me answer that question? Maybe that'll answer your question. Yes. Alright. So plug in 0 into the first part, what do you get?
0.
0. Okay? So that means that the parabola has a slope of 0 at that point. Now, plug in 0 into this, what's the slope? 1. So on this side, the slope is 0. On the other side, the slope is 1. And since the two slopes do not agree, we say it's not differentiable. So it has nothing to do with there's a less than or greater than or equal to over here. The question is, are the slopes the same on either side?
So
Since the slopes are not the same on either side, that's why it's not differentiable.
so if it was x instead of 1, that would be differentiable?
Say it again.
If it was x instead of 1, it would be differentiable?
If it was x instead of 1.
Yeah, like x is...
If it was x instead of 1,
Yeah.
bottom function.
You mean if this were x?
Yeah.
Yes. Yes.
So what is the definition of differential? If the slopes are even on both sides of the y-axis?
If they're the same on both sides. Not the y-axis, at the boundary.
Are there different rules for...
Like wherever.
Where here the boundary is. The boundary here is 0.
So like only on a piecewise?
Only for piecewise, yeah. Alright.
What does x cubed look like on the graph?
Yeah.
What does x cubed look like on
Isn't
this?
that like?
X cubed looks like this.
Well, I thought. How do you know if it's like? Or,
It's always blue.
wait, how do you
Alright. C.
moment.
Yeah, no more stalling. Alright. So let's do this one. 2x plus 2, x less than or equal to 1. So I'm just going to plug in 1 into that expression. That'll make it 4. 1, 2, 3, 4. And has a slope of 2. So here. Oops, I went too far down. Then 4 minus x squared for x greater than 1. So first I'm going to draw this in pencil. 4 minus x squared, so that means it crosses at 4 up here. 1, 2, 3, 4. But it's up here, and it's at 2 and negative 2. So it looks like this. When I plug in 1, what do I get? I get 3. Oh, that looks good. Alright, so I drew the whole graph of 4 minus x squared, but how much of this do I use?
The right side?
The right side, the greater than 1 side. So I just get rid of this part.
What is it, like a slope or a straight line?
Say what?
Is that like kind of slope?
This one? Yeah, it's a parabola, so it's kind of curvy.
It's not continuous.
It's not continuous and not differentiable, so neither.
Would that be an open circle?
Good question. Where is the open circle?
On
The
the
open
bottom.
circle is on the parabola, yeah. So if it's not continuous, it's going to be neither. Okay, if it's not continuous, then it's not differentiable there. Yes,
How is it not continuous?
because there's a break.
What does that mean?
For
If
D,
you have to pick up, well, never
Oh,
mind.
I got it, I see that.
Right, those two are not connected, therefore not continuous.
for D,
Say what?
for D, the graph doesn't go to 11.
Okay. All right. It's looking for x less than 2 though. All right, find the values of a and b that makes the function differentiable. You choose. You want me to do a or b? A? All right. Okay, wow. All right, good choice. Be sure to show blah, blah, blah. All right. We want to make the function differentiable and continuous. So that means, and there's 2 unknowns, right? So that means you need 2 equations. You have 2 unknowns, you need 2 equations. So in order to be continuous, what has to be true? They have to have the same value at 1. In order to be differentiable, the derivatives have to be the same value at 1. Okay? So let's look at both of them at 1. So I'm going to plug in 1 in the first part, so that's 1. 1 cubed is 1. Plug 1 into this expression. So that'll be, what? Negative 1 squared, which is positive 1. So that'll be a plus b. Did you follow what I just did?
Yes.
I plugged in 1 into the first expression. 1 to the third power is 1. I plugged in 1 into the second expression. 1 minus 2 is negative 1. If you square it, you get positive 1. So you just get a. And then there's nothing that's affecting the b, so it's just a plus b. No? You still don't get it?
So we don't have to worry about any other number but 1.
Right. We're only worried about the boundary. Now let's take the derivative. So the derivative would be 3x squared, right? So let's do the derivative on the side here. So f prime of x will be 3x squared oxabioi.
You can't use 1 because it's too small, right?
Well, technically you need chain rule to take the derivative here. So I'm just going to cheat. Do you understand that that's the derivative of that?
No.
It's just bring down the exponent, subtract 1 from the exponent.
Oh, okay.
What about
What's the derivative of b?
Oh, it's a constant, so.
1?
Very good. B is a constant, so it's 0. It's gone.
That's 1 gone.
Okay. So now I'll plug in the 1 into this. So there's something else lurking in here that you don't know about, but we'll just cheat and just say it's okay. So it's a good thing I chose that one. All right. All right, so plug in the 1. So that'll give you 3 equals, what's that? Negative 2a. So that means a equals negative 3 halves.
What?
Yep.
I just solved that equation. 3 equals negative 2a, so a equals negative 3 halves.
How come you're able to use 1?
Huh?
No, yeah.
I think you're able to use one and calculate that.
Why did I use 1?
Yeah.
Because that's the boundary.
But I thought 1 is lesser than 1.
Right, but if it, for it to be continuous, this will still have to have the same value there. Yes. Do you understand how I got 3 equals negative 2a? I divide by negative 2. Alright? So plug the negative 3 halves into the top one. So that'd be 1 equals negative 3 halves plus b. So that means b equals 5 halves. Right? 1 plus 3 halves is 5 halves.